Howdy, chemistry students of the world. You've just made yourself some benzoic acid. This one here. And you've made some benzoic acid by hydrolyzing some methyl benzoate. That's this one here. Methyl benzoate is an ester. And we hydrolyze this by adding water, hydrolysis, water splitting. We can split this ester apart, but it won't do it with just the water alone. We're going to need to add the catalyst sodium hydroxide. So we add the sodium hydroxide and the water. It splits this ester, and we get benzoic acid, and we get this one as well. This is a methanol. And it's the benzoic acid product that we want. This will appear as a white powder. And once we filter this off and we weigh it, we'll have a mass out that we've produced of benzoic acid. But the mass on its own doesn't mean much. We need to work out a percentage yield. So that's what we're going to do next. Okay, so let's say you started with a certain mass going in of methyl benzoate. So our mass in, I'm going to write with an M for short. M in was 1 gram of the methyl benzoate. And I got a mass out once I dried and weighed my benzoic acid sample. Let's say I got half a gram. 0.5 grams. So I got 0.5 grams coming out. So I've got a mass in and a mass out of the methyl benzoate in, benzoic acid out. So one of the things that's going to help us work out the percentage yield from this is I'm going to need to know the formula mass. I'm going to shorten that to FM here, and the formula mass of this one as well. So formula mass of methyl benzoate, formula mass of benzoic acid. So the formula mass of the methyl benzoate is 136.1 grams. The formula mass of the benzoic acid is 122.12 grams. So I've got a formula mass and a mass for both. So with this, I can work out the theoretical yield, how much I should have got if I used up all of my methyl benzoate. If everything reacted as it should have been, I'll have a theoretical yield of my benzoic acid. Of course, the mass out here is my actual yield. This is how much I weighed when I did it. So this mass here is the actual yield. So we want to figure out theoretical yield so we can have a good idea of what our percentage yield is going to be. So to work out my theoretical yield, first thing I've got to do is work out the number of moles I have of methyl benzoate. So my number of moles of methyl benzoate. So the number of moles of methyl benzoate can be calculated through using a formula. And the formula that relates mass and formula mass together. Now, one of the ways that I remember this formula is I draw it in a triangle of the different properties together. My mass, my number of moles, and my formula mass. I remember this triangle in the order that they go in through the mnemonic. Maths is not for me. Maths is not for me. So this is my mnemonic to help me remember this triangle. And why I like it in a triangle is because rather than just changing the subject of the formula in an equation, I remember that if I want to work out my number of moles, mass is on top of formula mass. So the number of moles is mass divided by the formula mass. Mass on top. If I did want to work out the mass at any point, I would know that it's the number of moles times the formula mass because they're next to each other. So the triangle helps me out like that. So I'm going to work at this number of moles, mass over formula mass. And I have both those properties for my methyl benzoate. So I can work out the number of moles for this one here. So my number of moles is going to be my mass over formula mass. The mass was just 1 gram. The formula mass was 136.1 gram. And if my trusty calculator is working, I'll be able to work out that number of moles. Why, it's 0.00735, of course. So we have a number of moles now of the methyl benzoate. So I'm going to fill that in here. Number of moles, N for number of moles, 0.00735. Okay, so I have a mass, a formula mass, and a number of moles of the methyl benzoate. But has that helped us get any closer to figuring out the percentage yield of benzoic acid? Well, it has helped a bit, because if I know the number of moles of this methyl benzoate, I also now know the number of moles of the benzoic acid. One of the reasons why balanced equations are great is because it lets me know how many of the amount of each substance relates to one another. In chemistry we call it the ratio, but I call it the recipe. If I need 2 parts eggs to 1 part milk, I'm able to scale up or scale down my recipe, but still maintaining the correct amounts. Same goes for a chemical ratio. 1 of these in equals 1 of these out. So 0.00735 in will equal 0.00735 out. So I have the number of moles of the benzoic acid as well. So if I've got the number of moles and the formula mass, I can work out another mass. Not the actual yield, but the theoretical yield. The mass that it should be if all of this is used up correctly. Let's go back to my triangle. So my maths is not for me. This time I want to work out a mass. My theoretical yield is the mass out. So M is going to be the number of moles multiplied by the formula mass, N times Fm. Number of moles times formula mass. The number of moles was 0.00735, and our formula mass for the benzoic acid was 122.12. When I multiply these two numbers together, I'm going to get a theoretical yield, a mass out that I'd expect. Where's that calculator again? Why, it's 0.89758. It's quite a big number. I suppose you could round that up if you like. So my mass out, this is going to be in grams. So 0.89758. So this is my theoretical yield. So I'll even write this down, my theoretical yield. My theoretical yield, let's just call that 0.9 for now to make it easier. So I can fill my theoretical yield in here, 0.9 grams. And this is theoretical yield. Well, I'm almost done, but to work out the percentage yield, the thing that we really want to know, is I'm going to look at the difference between these two. My theoretical yield is 0.9, but I only got 0.5, so I didn't get all the amount that I wanted. Maybe some was lost in the mass transfer of the experiment, or maybe the experiment didn't go to completion. There's lots of reasons why I wouldn't get 100% yield, but how much did I get? Well, let's work it out. So right at the top here, I'm going to say percentage yield equals the actual over the theoretical. Now I times it by 100, gets it as a nice percentage. So my actual yield was the 0.5. My theoretical yield was the 0.9. Times it by 100. And what do I get? Why, it's only 55.5 reoccurring percent. Was that a good yield? Well, you let me know in the comments section below. Make sure to hit that like button, hit that subscribe button for more great chemistry content.